Recently, Meta released something called Tribe V2, and depending on how you encounter it, you could very easily walk away thinking they built some kind of mind-reading AI. I mean, look at the demo. It literally says an AI model of the human brain. There are glowing brain maps everywhere. You have actual brain activity on one side, predicted brain activity on the other. So yes, if your first reaction is, hold on, the Meta just built a thing that reads minds, I get it. But after reading the paper myself, the paper itself, I think that is actually the less interesting way to frame what they released. Because what Meta seems to have built here is not a magical machine for reading your private thoughts. It's a model for predicting brain response patterns from video, audio, and text. And really enough, I think that may matter more. So in this video, I want to do three things, right? First, explain what Tribe V2 actually is. Second, explain the part of the paper I think is genuinely strange and important. And third, explain why I think the biggest story here is not mind reading. It's optimization. And to be clear, I'm not saying Meta released some production ad system that can perfectly model what billions of people feel. That would be way too strong. Although, you may have your reservations, I can understand. What I'm saying is that this paper points in a direction. And it's a direction I think creators, builders, and honestly anyone paying attention to AI should probably notice. So the paper is called A Foundation Model of Vision Audition and Language for In-silico Neuroscience. And that title already tells you a lot. So it's not framed as a consumer product, and it's not framed as a lie detector. It's not framed as a system that reads your hidden beliefs out of your skull. It's framed as a foundation model for neuroscience. More specifically, a trimodal model that takes video, audio, and text and then predicts brain activity. So according to the paper, Tribe V2 is trained on over 1,000 hours of fMRI data. That's functional magnetic resonance imaging across 720 subjects. And the basic idea is, instead of running a new expensive scan every time you want to test how the brain responds to some stimulus, maybe a model can predict a lot of that for you. That's already a big deal in research terms. The demo page leans into this hard. It talks about mapping brain functions at scale. It shows a pipeline where video, audio, and text embeddings go through a transformer and then into a subject block that maps them to predicted brain activity, and presents this as a way to transform months of lab work into seconds of computation. So right away, I think there are two stories you can tell here. So the headline story is that Meta built a brain AI. The other is a more technical story, which is it built a large multimodal encoding model for predicting fMRI responses. And those are not the same story. So when most people hear predicting brain activity, they imagine something much more personal than what the paper actually seems to support. They imagine a system that can decode your thoughts, intentions, secrets, maybe even your beliefs. But what we see here is something about average or group level prediction more than personalized thought extraction. So with the demo, you have an average subject view, and then the paper focuses on generalization against subjects, tasks, and stimuli. Now some private thought decoder, right? And then what we have is that basically, so there's an interesting finding, right? So if you look in section 2.3 of the paper, I think the authors say something about the data sets they were looking at. So they could see that Tribe V2's predictions often provide a more accurate estimation of the group response than the recordings of most individual subjects. And I think that's really cool because it's trained on a group. It actually turned out to be more accurate than if you compared it to individual responses that turned out. The group response, the aggregate data, tended to be a much better predictor than any individuals, right? And in some settings, it can be more representative of the typical response. Now, this is the cool thing. It can be more representative of typical response than an actual person scan. So in one case, you would see what it predicted and compare it to the scan of a person. And then in another case, you would see what it predicted and then compare it to the scans of many people. And you find that with many people, because it converges its representations based on what we're seeing as similar across many brains, it tends to be more accurate that way because it is generalized across the group, even on actual individuals. Even though they may differ in certain ways, it tends to be a little more accurate than something else is a little more baseline, right? So it's somehow more real than a human brain. And it it actually also kind of subverts the idea that it's supposed to predict any individual mind, right? So it's not that the model is somehow more real than a human brain. It's just that it's real scans can be noisy, they can be messy, they're distorted by motion or device artifacts or physiology, right? But the model is learned to produce something closer to a cleaner canonical response, right? So it's a machine that it doesn't peer into some inner psychic truth. It just gets good at approximating the stable signal underneath a bunch of noisy measurements, right? So if you care about the group pattern, the shared response, the common structure, then a really good, strong predictive model can sometimes give you a cleaner estimate than any one individual scan can. And there's this idea of the in-silico experiments where it goes on into neuroscience, right? So the other part is it's just not presented as a benchmark model, but the whole point is that it lets researchers simulate experiments, right? So if you look at the paper, it walks through classic visual and language paradigms and shows that the model can recover a bunch of known findings like places, faces, bodies, speech, semantics, you name it, right? And it maps them to specific regions, right? So that's what makes the digital twin language really tempting. Because even though I still think that phrase can get a little too grandiose if you're not careful, right? But the strongest version of the claim is that they built a useful simulation layer for certain kinds of brain response research. Right. So what other angles are there to this? There's a scaling law. The other thing is that they figured out, because they did try V1 and they only had like 4 subjects for that. They did this with 720 subjects and they realized that more training data per subject gives better prediction performance, right? So this is the same scaling laws you're seeing in the LLM space, which means if we can get more and more data on brain scans, kind of like almost like the way we have the models out there that predict protein folding structures like AlphaFold, right? So with this one, it's the same thing. The more data you give it, the more accurate it gets. So it looks like a pretty interesting future, right? If you have better modalities, like more modalities, other than audio, video, and whatever, I don't know which other modalities could be there. But like with more data, more modalities, future versions could be more robust, more general, more personalized, maybe just simply easier to use. But again, I can see why people might be afraid of this. It's just interesting because the model is open source and you can try it. But I also see a bigger story. So if you stop obsessing over whether it's mind reading, you can see that the more practical implication would be something to do with optimization. So this would mean that platforms like Meta won't need perfect access to your inner life in order to shape what you see. They just need improving models of what kinds of inputs they like to produce, what kinds of outputs. And that's the scary part. It's both scary and exciting. If you are a video maker, maybe you could use it to optimize your thumbnails and your titles. But if you're an ad maker, well, I don't know about that. So you can increase things like watch time, clicks, comments, retention curves, conversion, you name it, right? That's the interesting thing. It's not already an ad targeting engine, but we can see where that might be going. But it should be interesting to advertisers. So I would kind of like to look into how you can use it as a creator, and maybe I might make a future video about this where we try, because it's free and open source. I think you can get it via space for hugs, Hugging Face. You can get it via there, and we can try and experiment with it to see what we could build with it. But then there's the biggest scary implication, which is what does this mean for advertisements? And I think that's an interesting question. I'd like to see what you guys think about in the comments. So that's pretty much it. That's about this paper. I've been mumbling my way through it. It's the first video essay where I'm trying to actually look at a study and talk about it. Well, not a study, but a scientific paper and talk about it. I've done studies. And let me know what you think about this new development and if you want to see more of this kind of video. Until next time, ciao Bella.